Hello, my name is Jackie Patton, and this is my experiment on the iodine clock reaction and why it occurs. I'm first going to show you my little, my little experiment setup. I'm so sorry, my experiment setup, and then I'll get into why this reaction occurs the way that it does occur. I first like to disclose that this experiment did not go the way that I thought it was gonna go. I did not get the results that was shown to me through the video that we had via Canvas. And I did try some of his tips and tricks, and I'll kind of show you, and excuse my camera angles and things like that. I'm working off of my phone, and there's no, like, I can't flip the camera. So like this is kind of like my whole little setup area over here. So I had like my distilled water, my filtered water. This was my B solution right over here. This was my final product, my final solution. Excuse my fingers. This right here. And as you can tell, it's very cloudy. It's not clear. Like I did heat up my B solution right up here. You can even see like the condensation and stuff like that on it, or I hope you can see that condensation on it. But yeah, it just did not react the way that it was supposed to react. Like I can even see some flakes and things like that on the top of the cup. So maybe it just didn't get filtered correctly. And then that was my solution A right over here. And then I had like my iodine, my hydrogen, my starch, and then my my vitamin C over there. And I did use like 500 milligram tablets, so I had to like crush 4 instead of 2. But yeah, so that was my little like setup, and then I had coffee filters as well to like filter out the little thing to filter them out. I don't have beakers here at home, so I had to just use what I had to do. I ran out of my small cups that I bought for the last previous experiment, so I have to go get some more for the next one. But to get into why this reaction occurs and things like that, the iodine clock reaction occurs. It involves a transformation of colorless substances to colored ones. This reaction works due to the complex interplay of various chemical reactions happening simultaneously. The reactants are colorless, but as the reaction progresses, iodine is produced, leading to the formation of the blue-black color. The timing of when this color change occurs depends on the concentration of the reactants and the reaction condition. In the iodine clock reaction, several reactions are happening simultaneously, and then one key reaction involves the oxidation of iodine ions by hydrogen peroxide in an acidic solution to form the molecular iodine. This reaction is crucial because it leads to the formation of the blue and black color that signals the end point of the reaction. And then on the flip side of that, the other important reaction, there's another one that's involved, but just to name the two that are the most important, I believe, is the reduction of iodine back to iodine ions by thiosulfate ions. And excuse me if I'm mispronouncing those elements and things in those ions. So it's kind of like a competition between the two reactions on on where hydrogen peroxide oxidizes iodine ions to form iodine, while the acid reduces iodine back to iodine ions and creates an interesting back and forth dynamic. And then so how the reaction stops going back and forth is eventually like the vitamin C gets all used up, and due to the excess of hydrogen peroxide, leading to the accumulation of iodine, which then complexes with the iodine ions and starts to form the triidine complex, which is the specific concentrations of the reaction. And the temperature of the reaction mixture plays a significant role in determining how quickly the color change occurs. The whole experiment is kind of like a chemical magic show where the color change happens at a specific moment, creating a very visual, like, striking effect. And like they said in the temperature, I did like heat, I don't know if I mentioned this earlier, but I did heat the solution B up, like the man did in the video, but that didn't really help me at all, honestly. But yeah, trial. I would love to do this again, maybe sometime. And like I can even see, like, right now my solution is doing something weird. Like I'll show you. It's kind of like casting, Like, I don't know if you can see around like the edges and stuff, but yeah, I'm not sure what happened exactly, but yeah. I hope you have a great weekend and a happy Easter. Thank you.